In this lesson, I'm going to show you a powerful functional programming technique called currying. Unlike what you might think, this has nothing to do with food. This is named after this guy, Haskell Curry. So back to the problem from the last video. Let's extend this program and create a function for wrapping a string inside a span element. So over here, we create a new function, wrap in span. And let me copy this code from here and then replace div with span. Pretty straightforward. Now there is a problem in this code. We have a bit of duplication. These two expressions look very similar. The only difference they have is in the type of element. It would be nice if we could parameterize this function. So instead of wrap in span, let's call it wrap and give it two parameters, type and input string. Then instead of the span, we're going to render the type. Okay. Now let's get rid of wrap and div and instead use our new function, wrap. Finally, let's log the return value of the transform function on the console. Save the changes. So here's what we get. JavaScript, undefined. That doesn't make sense. Here's the reason. This pipe function essentially builds a pipeline. The output of each function ends up being the input of the next function. So what is the output of the two lowercase function? It's our input string in lowercase, right? So that gets passed to a wrap function. Now this function has two parameters, type and input string. So our input string in lowercase gets passed as the type argument, and the second argument becomes undefined. That is the reason why we get this result. Now, what if we call wrap and pass div as the type of element? Let's save the changes. Back in the console, we get this error, expected a function, because every argument to the pipe function has to be a function. In this case, we're calling the wrap function and give it div as the type of element. So this is going to return a string. We cannot pass a string in the pipe function because we cannot build a pipeline with a bunch of functions and a string. It doesn't make sense. So here's the problem you're facing. We have a function with two parameters, but what we need in this pipeline is a function with a single parameter. And that's the problem that currying solves. Let me show you. So I've created a separate file called currying. Let's study currying in isolation, and then we'll come back to our main file. So let's say we have a function for adding two numbers, a and b. Here we return a and b. Currying is a technique that allows us to take a function that has n arguments and convert it to a function that has a single argument. So to apply currying here, we get rid of b as the second parameter. And instead of returning this expression, we're going to return a function that takes a parameter called b. And then inside this function, we're going to return a plus b. So when we call the add function, let's say add1, this is going to return a function. Let's call it add1. So every time we call this function and give it a value, it's going to add 1 to it. Okay. Now, in this case, we don't need to store this function in this constant. We can call add1. We know that this returns a function. So we can call that function and pass our second argument. So with currying, instead of separating our arguments with comma, we separate them using parentheses. But what matters here is that we have a function with a single parameter. Now we can also rewrite this function using an arrow function. So let's declare a function called add2. Now this function should take a parameter called a and return a new function. So a goes to. Now here we should return a function that takes a parameter called b. So b goes to and returns this expression. So once again, instead of separating our parameters using a comma, like a and b goes to a plus b, we are separating them using arrows. This is the result of currying a function. Now let's apply this technique in our main program. So the problem we have here is that the wrap function takes two parameters. We want to apply currying here, so we end up with a function with a single parameter. So to separate these parameters, instead of a comma, we're going to use an arrow. So we don't need parentheses because we have a single parameter. Type goes to, string goes to this expression. This is our curried function. Now, here's the interesting part. When we call wrap and pass div, we get a function instead of a string. So we can pass that function as another step in our pipeline. Let's save the changes. And here's the final result. So we wrapped JavaScript in a div element. With this new implementation, we can replace div with a span or any other elements. Save the changes. There you go. So we don't have to create so many functions for creating HTML elements.